if two 300 volt full scale voltmeters V1 and V2 having sensitivities of 100 kilo ohms per ohm volt and 150 kilo ohms per volt are connected in series to measure 500 volts, then okay, so this is one of the important model of questions. Okay, so they will definitely give this model of questions. Okay, so in every 2 years in one question paper this model of questions will be there. Okay, so that means in every 2 question papers in one state, okay, there will be one question like this. Okay, let's see. So what they told, 2 voltmeters are there. Okay, so voltmeter 1 having a sensitivity they have given as 100 kilo ohms per volt they have given, and what is the reading of this one, what is the full scale reading, 300 volt it is. Okay, 300 volt. So that means for 1 volt, what is the resistance? 100 kilo ohms. Now total voltage of this one is nothing but 300 volts, means total resistance of this one, internal resistance of this voltage source is not voltmeter. Okay, so not voltage source, voltmeter is nothing but 100 kilo ohms into 300. Okay, so we can write down as, if you multiply, okay, so directly we'll get 30000 kilo ohms. Otherwise we can write down as 30 mega ohms of resistance it is. Okay, resistance of the first voltmeter. Okay, similarly second voltmeter, what is the sensitivity they have given? 150 kilo ohms per volt they have given. This is also having a full scale reading of 300 volts. That means for 1 volt what is the resistance? 150 kilo ohms. For 300 volts what is the resistance? So 150 into 300. Okay, so you will get 15 into 3 is nothing but 45. Okay, so 45 0 0 0. Okay, so in terms of kilo ohms, otherwise we can give this is R2, so that will be equal to 45 mega ohm. Okay, so this is 45 mega ohms. Okay, so this is the 2 resistances. Now what they have given, these 2 we are using. Okay, so to measure some voltage, so what is the voltage they have given? Let's take as DC only, no problem. So what is the voltage, total voltage they have connected in series to measure a total voltage of 500 volt. Okay, so 500 volt it is, and I am connecting 2 voltmeters. So this is nothing but voltmeter 1 and this is nothing but voltmeter 2. Okay, so voltmeters it is. Okay, so but in general it is a circuit, right? Okay, so circuit which is having 30 mega ohm, first one is having 30 mega ohm and second one is having 45 mega ohm. Okay, 45 mega ohm. Now let's check. Okay, so to voltage division only. Okay, so total voltage is this one, some voltage will come across this and some voltage will come across this. So voltmeter 1 reading, let's check. Voltmeter 1 reading is nothing but, so total voltage 500 into 500 volts into 30 divided by 30 plus 35. Okay, so 30 divided by 30 plus 45, 30 plus 45 is nothing but 75. Okay, 75. Okay, so this is the first voltmeter reading. Okay, so let's calculate what you will get. 15 2s and 15 5s. Okay, so 5 1s, 5 hundreds. Okay, so you will get 200 volts. Okay, so V1 is equals to 200 volts, then automatically total is 500, right? No need to do V2, so directly V2 is nothing but 300 volts. Okay, so this is the 2 voltmeter readings. Okay, so you can get, so V1 will read 200 volts and V2 will read 300 volts. Okay, so that is the answer for this. Okay, so V1 and V2 will read 0 ohms each, 0 volt each. So how these options are correct? Generally it's not possible at all. Okay, so we have to check some current rating also. Okay, so whether current in this one is satisfying or not satisfying also we can check. Okay, so what is the current rating of this one, or what is the sensitivity of this one, means you can check voltage divided by what is the current, voltage divided by ohms. Okay, so then we can get, so 1 by 100 kilo ohms. Okay, so that is nothing but current rating, first one current rating. Okay, so that is first one. Okay, so first voltmeter current rating, so that is nothing but, so 1 by this means 0. You see how many zeros? Okay, so otherwise 0.01 milliamperes. This is the first voltmeter current rating. That means more than that current we cannot send through first voltmeter. And second voltmeter, okay, so generally I2 is nothing but, so 1 by this one. Okay, so 1 by 150 kilo. Okay, so 1 by 150 kilo. So we can calculate. Okay, this is nothing but, so total, so this is milli, you will get 1 by 150 means, So we'll just do, okay, so 1 by 150, so 150, 0, 0, and again 0, okay, so 0.01, okay, 0.00, then 15 into 15, 6, okay, so you will get 15, 6, you will get again 6, 6, okay. So anyway, you will get the answer as like this, okay. So 0.0066 milliamperes it is, okay. So milliamperes. So now whenever both are connected in series also, it should not so overflow. That means current in this one should not cross that limit, okay. So whenever these two are connected in series, okay, let's check. 500 volts is connected total. 30 plus 45, what is the resistance? 75, okay. So 500 divided by 30 plus 45, what is 30 plus 45? That is nothing but 75, okay, 75. So then in terms of mega it is, so directly we can write down 10 power minus 6 it is, okay. So let's calculate 15 fives and 15, okay. So with the 5 we can do, okay. So 15, so then we can get 100 here, and 15 ones, 15 6, okay. So and again 6.66 you will get, okay. 6.66 watt it is, okay. 6.66 microamperes it is, okay. So in this 6.66 microamperes of current is flowing. That means what it is, so if you convert into milli, you will get 0.0066 milliamperes, okay. So there is nothing but 0.0066 milliamperes you will get. That means second, this one is having the limit, no problem. This one is also having the limit. So that means this current is less than this current or equal to this current or less than this current only. So directly we can use, if this current, okay, whatever current you are getting here, if this crosses this one, if this value is greater than this one, then automatically, so it will be, so one of the voltmeter will definitely burn, okay. So that if one is burning means then both will not read, because both are connected in series, okay. So that's why it should not cross this limit, okay. So that's how you will get this option. So if it is crossing, then both will read 0 only, okay, like that. Understanding, right? So anyway, answer for this question is B only. Just check how it is possible means, if 600 volts is there, then automatically what happens? It will overflow. That means current in the meters is greater than this one, okay. So whatever current is flowing in the series, then it should not cross this limit, then only it is possible. If it crosses this limit or this limit, then automatically, so there will be zero reading in the voltmeters, okay. So anyway, for this question answer is the second option only, okay. So V1 is 200 volts and V2 is 300 volts, okay. So like this we have to answer this model of questions, okay. And the next question is, a 5 ampere ammeter with 0.3 ohms resistance is to be used to measure current in a circuit which draws a current up to 20 amperes. Then shunt resistance to be used along with the ammeter is, okay. So these are normal questions only. In any exam this model of questions are possible, okay. So let's see, 5 amperes current, okay. So 5 amperes ammeter they have told, okay. So the normal current is 5 amperes now. So that means meter current is 5 amperes. Now what we have to do? So we have to measure a circuit which draws a current up to 20 amperes. That means the meter range we have to extend up to 20 amperes. Okay, so range has to extend up to 20 amperes. So I is nothing but 20 amperes. Now meter resistance RM they have given as 0.3 ohms. So now what they are asking? Shunt resistance they are asking. Okay, directly we can use the formula RSH equal to RM divided by M minus 1. Okay, so RM divided by M. What is M? Multiplication factor. Okay, so that is nothing but, or shunt multiplier we can call. So that is nothing but I by IM. Okay, that is nothing but 20 divided by 5 you will get, so 5 fours. Okay, so 4 is the multiplication factor. So RSH value is nothing but 0.3 divided by 4 minus 1 is nothing but 3. So 0.3 divided by 3 means 0.1 you will get. Okay, 0.1 ohm. So this is the answer. Okay, for the ammeter we have used this formula. Okay, so to calculate the shunt resistance we have used this formula. If it is a voltmeter, if they are asking what is the resistance you have to connect in series, so what is the formula we have? So RSC is equals to Rm into m minus 1. Okay, similarly m also multiplication factor, extended range divided by old range. Okay, here also same. Okay, so new value of current divided by old value of current, otherwise extended value. Okay, this is nothing but extension value, this is nothing but old value. Okay, extended value divided by old value is nothing but you will get the multiplying factor or shunt multiplier. This is nothing but series multiplier. Okay, so for the ammeter, where we have to connect, for any of the ammeter we have to connect in the shunt. Okay, so we have to connect in shunt or parallel or across the meter we have to connect for the ammeter. Okay, so for the voltmeter, generally where we have to connect, in series with the meter we have to connect like this. Okay, this is voltmeter and generally load will be connected like this. Okay, so for the ammeter load will be connected like this. Okay, so these are all just questions, we have discussed more deeper concepts also. Okay, so anyway, answer for this question is 0.1 ohms. Okay, so next question, two ammeters, one with full scale current of 1 milliampere and internal resistance of 100 ohms and the other with a full scale current of 10 milliamperes and internal resistance of 25 ohms are connected in parallel. What is the total current these two meters can carry without any meter reading out of scale? Okay, so they have given two meters they have connected in parallel, and what is the maximum current they can measure without that means without any meter reading out. Okay, that means out of scale it should not cross. Okay, so what is the first meter? First meter is having a range of 1 milliampere and second meter is having a range of 10 milliamperes. Okay, so generally these two are the meters. Okay, so meters I am just connecting. This is the first ammeter 1 and it has a range of, okay, so it has a range of 1 milliamperes and second ammeter is having a range of 10 milliamperes. That means in this the current is nothing but 1 milliampere, in this the current is nothing but 10 milliamperes. Okay, so like that. So what is the internal resistance? It is nothing but 100 ohms. Okay, so for this one 100 ohms, for this one it is what is this one, 25 ohms it is. Okay, so internal resistance, otherwise meter resistance they have given, that is 25 ohms they have connected in parallel. Okay, so they have connected in parallel they are mentioning. Okay, so what is the total current these two meters can carry without any meter reading out? Okay, so without any meter reading out, what is the total current these two? Okay, so remember one thing, whenever two meters we are connecting in parallel means their voltage must be same. Okay, voltage across this and voltage across this, I will just calculate. Okay, so what is the voltage it is possible. Okay, so what is the total voltage possible individually? Okay, so what is the current in this one? 100 milliamperes. Okay, not 100, 10 milliamperes. Okay, so 10 milliamperes into 25 means it is nothing but 250 millivolt you will get. Okay, so 250 millivolt across this instrument individually. Okay, so not in parallel, individually. Okay, so across this one, okay, so what we will be having 1. Okay, and this is nothing but 100, so 100 millivolt. So whenever these two are connecting, for example, you tell me if 10 milliamperes current is flowing in this one means meter resistance will not change, so total voltage is nothing but 250, so then automatically here it will be problem. 250 millivolts of volts means here we have the limit of 100 millivolts only, so total, okay, a maximum of 100 millivolts only is possible across this. Okay, so across this what is the maximum voltage possible? So it is 100 millivolts only. Now we have to calculate, when 100 millivolts, what is the current going inside? 1 milliampere. Okay, this is same only. Okay, if 100 millivolts, okay, 100 millivolts is across this and meter resistance is nothing but 25 ohms. Okay, so 25 ohms, so we have to just calculate what is the current flowing in this. Okay, so 25 force. Okay, it is nothing but 4 milliamperes. Okay, so 4 milliamperes. Okay, so here 1 milliampere, here it is 1 milliampere, here it is 4 milliamperes, so total it is nothing but 5 milliamperes. This is the answer. Okay, so we have different methods to solve, but you see the circuit models. Okay, whatever circuit model I am giving here, this is so simple to understand. Okay, so you should have clarity about whenever two ammeters are connecting, we are connecting in parallel, right? Okay, so which is matters here? Voltage is matters. Okay, so that's how you have to understand. Okay, so anyway, answer for this question is 5 milliamperes. Okay. So anyway, in our next session, we will see some more questions like this, and please understand all the previous year questions are so important. Okay, so once you solve previous year questions, you will definitely get your rank. Otherwise, you will definitely get your marks a little bit near to the selection. Okay, so that's what so important for us. Okay, thank you so much.